Okay, so this is like take 2 of the beginning of the lecture for Tuesday, September 15th, because I was recording it and then a gravity storm happened, the camera fell off, I lost that bit. So this is going over the graphing worksheet, okay? So I'll tell you right now, later on in another version, or later on, you'll see me going over the question about the force and acceleration graph, and you'll hear me talking about number 12. So what I want to go over now, just the way it played out, is the questions on the back about how you handle variables changing. So the question was asked, you have F equals mv squared over r. So this is relating to like having something move in a circle. So in this case, here's a Albert Einstein action figure, and we're going to swing Albert Einstein around over my head. So this would be the mass of Al, how fast he's going, and this is going to be the radius. Okay, so you have 3 variables, mass, velocity, and radius. So one of the key things that you've got to be able to do is look at an equation and go, okay, hey, what's going to happen here? Well, clearly, the more mass that you have, the more force that's going to take. So, you know, if I try and swing Hank the bowling ball around on the end of a string, that's going to take a lot of force because it has a lot of mass. If I make Al go faster, that's going to require more force. Radius, though, is an inverse relationship. So here's the terminology. You would say force is directly proportional to mass, it's inversely proportional to radius, and it's directly proportional to velocity squared. Okay, so that's the terminology. So on that sheet, when you look down there on number 18, so you've got F equals mv squared over r. So on that first one, you have the velocity is doubled. So there's 2 ways you can do this. One is the elegant mathematical way. And you go, okay, well, if this is my initial set of conditions, my new one is going to be mass times 2v squared over r. Well, once I square that, that becomes mass 4v squared over r. So to keep the 2 sides equal, if this sides go up by a factor of 4, that means my force goes up by a factor of 4. Okay? Some people like this approach. It's elegant, it's mathematical, it's wonderful. Now, some people flip out and they go, oh, I like numbers. Fine, we'll make up numbers. The easiest thing to do, because you have mv squared over r, is to choose a mass of 1 kilogram, let it go at 1 meter per second squared, and let it move in a radius of 1 meter. Okay, so that would be like, radius is about 1 meter. 1 meter per second is about like this. Okay, and you all know what 1 kilogram is. Okay, so 1 kilogram. So you crunch all the numbers, you would get 1 Newton. So it would take 1 Newton of force to take a 1 kilogram mass, make it move in a circle with 1 radius, or a 1 meter radius, and moving at 1 meter per second. So this is my initial set of conditions. So now, we're going to change it. So then we're going to double the velocity. Okay? So then my new calculation is going to be 1 kilogram times 2 meters per second, but that's going to get squared. I'm going to still divide it by 1 meter. So if you do the math here, you get 4 newtons. And again, you'll notice that this goes up by a factor of 4. So anytime something is squared, if you double it, it goes up by a factor of 4. If I were to triple this and make it go 3 times faster, this would go up by a factor of 9. Okay? So now, then when you get to that last one, if the radius is halved. So now I want to talk about changing the radius. So again, the mv squared part is going to stay the same. So if I double the radius, this is going to be mv squared over 2r. So in other words, instead of moving with a radius like this, I want to move with a much bigger radius. And you all have experienced that. When you all take a turn in your car, a really, really small radius, a really tight turn, that takes a lot of force. If you increase that radius, then that requires less force. So this basically becomes 1/2 times mv squared over r. So if I multiply this side by 1/2, that means my force will become half as much. So if I double the radius, my force becomes half as much. Now, if I have the radius though, then if I have mv squared r over 2, then now I'm going to shrink that radius and keep everything else the same. I'm dividing by 2 in the denominator of the denominator. The 2 is going to flip up, and then that's going to become 2 times mv squared over r. So this requires a little bit of thought. So if I double the radius, the force becomes half as much. But if I have the radius, in other words, I make that radius half that it was, then I double the amount of force. So that's what you have to be careful when you're down below, working in the denominator. Now, if I double the mass, hey, I double the force. If I double the velocity, I go up by a factor of 4. If I double the radius, the force goes down by a half. Okay? So that's what you've got to be able to think through. Now, on the other sessions, I go through the answers to the question on number 12, and then the question on the force. So all of those are answered on the next video. So there we go, kids. Got any questions beyond that, just email me. Make sure that you are getting your assignments turned in. Some of you need to work on that. Also make sure that when you are sending me these CAM scanner PDF files, make sure that you're putting like your last name, Smith, whatever that is, and then like whatever block that you were in. So if you're in first block, go Smith 1. If you're in third block, Smith 3. If you're one of my virtual learners, go Smith virtual. Okay, whatever block that you were in, put that at the end, because that way, when I'm sorting through the incoming PDF files and emails, I know which block that they go to. Okay, so this is vital. You have to start putting this at the end of your name and then a hyphen. So like this one, this assignment, you would go like Smith 1 hyphen and then like graphing assignment. Okay, so that way I know whose it is, I know which block that you're in, and I know what the assignment is, because there's a whole bunch of stuff that I have to keep track of. So anyway, there you go. And I've sent out the link if you want to zoom in during third block, because I figured out the links that I sent you all out weren't working, so we're just going to do it directly through email. Okay, that's the story. See you, kids.